Hello, YouTube. I last night I came across this WMAP highlights here at the NASA website, and it struck me as really funny. And this is the WMAP. If you didn't know, was a probe that was sent out to measure the cosmic microwave background of our universe. Um, the radiation that was left over after the Big Bang. The WMAP wins the Fundamental Physics Award for detailed maps of the early universe that greatly improved our knowledge of the evolution of the cosmos and the fluctuations that seeded the formation of galaxies. The prize is awarded to Charles L. Bennett, Gary Shaw, Norman, you can read these here, 27-member WMAP science team. The 2018 Breakthrough Prize of Fundamental Physics. The Gruber Foundation proudly presents the 2012 Cosmology Prize to Charles Bennett and Wilkinson Microwave Anisotropy Probe Team for their exquisite measurements of anisotropies in the relic radiation from the Big Bang, the cosmic microwave background. These measurements have helped to secure rigorous constraints on the origin, content, age, and geometry of the universe, transforming our current paradigm of structure formation from appealing scenario into precise science. Wow. And this is going to be, you'll see why that is so damn funny here in just a second. And there's their pretty awards there. Alright, let's get rid of that. And I'm going to give you a little history in case you don't know what the cosmological principle is. In modern physical cosmology, the cosmological principle is the notion that the spatial distribution of matter in the universe is homogeneous and isotropic when viewed on a large enough scale, since the forces are expected to act uniformly. Remember this, uniformly throughout the universe, and should therefore observable produce no observable irregularities in the large-scale structuring over the course of evolution of the matter field that was initially laid down by the Big Bang. In other words, no matter where you look in space, everything should be uniform. There shouldn't be any differences. Everything should look the same in our universe, no matter where you're looking from. Okay? The cosmological principle is usually stated formally as viewed on a sufficiently large enough scale, the properties of the universe are the same for all observers. This amounts to the strongly philosophical statement that the part of the universe which we can see is a fair sample and that the same physical laws apply throughout. In essence, this is a sense says the universe is knowable and is playing fair with scientists. The cosmological principle depends on the definition of observer and contains an implicit qualification and two testable consequences. Observers means any observer at any location in the universe, not simply any human observer at any location on Earth. As Lytle puts it, the cosmological principle means that the universe looks the same whoever or wherever you are. The qualification is the variation in physical structures can be overlooked provided this does not imperil the uniformity of conclusions drawn from observation. The sun is different from the earth. Our galaxy is different from a black hole. Some galaxies advance toward rather than recede from us, and the universe has a foamy texture of galaxy clusters and voids, but none of these different structures appears to violate the basic law of physics. Two testable structural consequences of the cosmological principle. This is important. Homogeneity and isotropy. Homogeneity means that the same, what I just said, same observable evidence from a fair sample. Isotropy means the same observable evidence is available while looking in any direction in the universe. Origin, um, this goes all the way back to Isaac Newton himself and Copernicus and heliocentrism, geocentrism, the whole thing. Um, we're not going to talk about flat Earth, but we are going to talk about flat universe versus curved universe. So we got that down now. You know what the cosmological principle is. Okay, so we're going to click over here and we're going to I tell you what, let's okay. Well, I'm going to read you this article first here. And this is going to say a lot. This is put out in 2013 now. But this has been going on for a long time. This has been going on since the 90s, I guess. It's been going on a long time. And the reason why is because they've had to test and retest and retest and retest and do, because they couldn't wrap their mind around the data and the evidence they were getting back. Planck satellite confirms this was the latest one that they sent up there to do experiments and whatnot on our cosmic microwave background. Most cosmologists, sorry, I'm drunk as piss, I can't talk, will not admit it publicly. Perhaps over a beer, they would tell you what is happening. Yeah, because it's shutting them down hard. Observations over the last 50 years, culminating with the Planck satellite results, March 2013, set modern science on a counter-revolution leading closer to ideas formed 500 years ago. Today's cosmology Today's cosmology is based on two broad principles. The Copernican principle, we are not in a special place in the universe, and the cosmological principle, the Copernican principle plus isotropy, which we talked about. The view from anywhere in the universe looks all about the same. Starting with early studies of the cosmic microwave background, and in recent years culminating with results from the COBE, when the WMAP satellite scientists were faced with a signal that the larger scales of the universe, a signal that pointed right back at us, indicating that we are in a special place in the universe. Without getting overly technical, the Copernican and cosmological principles require that any variation in the radiation from the CMB be more or less randomly distributed throughout the universe, especially on large scales, resulting from the WMAP satellite in the early 2000s. Yeah, I thought it was about 96, but maybe it was 2000. Indicated that when looking at large scales of the universe, the noise could be partitioned into hot and cold sections. And this partitioning is aligned. Now pay attention to this part here. This is important. This partitioning is aligned with our ecliptic plane and equinoxes. This partitioning and alignment resulted in an axis through the universe, which scientists dubbed the axis of evil, because the damage it does to their theories. The axis is aligned to us, Lawrence Krauss commented in 2005. Quote, but when you look at the cosmic microwave background map, you also see that the structure that is observed is in fact in a weird way correlated with the plane of the Earth around the sun. Is this Copernicus coming back to haunt us? That's crazy. We're looking out at the whole universe. There's no way there should be a correlation of structure with our motion of Earth around the sun. The plane of the Earth around the sun, the ecliptic, that would say we're truly center of the universe. Most scientists brush the observation off as a fluke of some type, and many theories were created to explain it away. Many awaited the Planck mission. The Planck satellite was looked upon as a referee for these unexpected and unwelcome results. A little more background on this. There was a movie that came out called The Principle when these first WMAP readings came out that just astonished everybody and pointed to the fact that we are at the center of the universe, and not only that, all everything in the universe is lined up like on shelves around us, like we everything is in relation to us. There we are, and that just flipped everybody's wig. They couldn't handle it, so they just kept sending shit up there to do the same damn test over and over again, trying to figure out what it couldn't be right. There had to be some either contamination or there had to be some kind of fault in the instruments. Um, I'll go on here. Planck reported back though that they started looking at the smaller scale with this Planck satellite because hence Planck was the small guy reported back in and in fact verified the presence of a signal in even higher definition than before. Basically, this satellite came back and said 110% yes, this is right. There are cosmologists and scientists who recognize the signal for what it is, and recent articles have started talking about the need for some new physics to explain the results. Even on the Planck mission website, Professor needs to get a better name states our ultimate goal would be to construct a new model that predicts the anomalies and links them together. But these are early days. So far, we don't know whether this is possible and what type of new physics might be needed, and that's exciting. Other observations have independently validated the axis of evil in recent years, and this adds credibility to the CMB observations. These observations include galaxy rotation alignments to our tiny part of the universe. Very recent reports include observations of alignment between sky distributions of powerful extended quasars and some other subclass of radio galaxies, and a plane passing through the two equinoxes and the north celestial pole. Also, anisotropy and of cosmic acceleration and union 2 type Ia supernova appear to be aligning with the CMB features. All this supports the contention that the Copernican principle and cosmological have effectively been invalidated without even discussing the quantization of various astronomical features about us, which further support the contention. In other words, the entire structure of the universe, as mainstream science has taught us, is going to have to be reworked and changed. It's no longer valid. That's a big deal. A very big deal. And they've been going back and forth on this for a minute now, trying to figure out what the hell they're going to do about it. And it's no longer going to be able to be ignored. The question is, what will modern science do now? Will they invent additional parameters to keep the current theories alive like they normally try and do? In addition to those already added, dark matter, dark energy, redshift, expansion, Big Bang inflation, or will they consider the possibility that we are in a special place as observations clearly indicate? Well, this shit is going to flip everything upside down. I mean, this is a super, super big deal, and I can't believe nobody is talking about it. I mean, the Big Bang, the idea that our everything is expanding out from the Big Bang is wrong. All of this, their whole theory about dark matter, dark energy, antimatter, redshift is wrong. All that's what this is telling them. It is serious. Um, Let me go over here. I gotta go to I gotta go to the anomalies. I wanna go over these anomalies um, with you all. That let's look over this here first. Anomalies in the Big Bang afterglow. CMB cold spot. Okay, huge hole in space lacking in all forms of matter, stretching 1 billion light years across. Could be an imprint of another universe bouncing against ours. The axis of evil. A noticeable temperature variation. See, imagine this is the universe right here. Okay, and this is the axis of evil that splits the two hemispheres. Okay, concentric circles. These circles are non-random points in the CMB data where the temperature varies. Could be proof that our universe wasn't the first form in the Big Bang. Okay, this is I don't think this is the one I want to go over here, but I'll go ahead and read this to you. As the theory goes, some 14 billion years ago, there was nothing focalized in a single, highly dense point. Then that nothing exploded, hurling the ingredients for everything we see in the universe into existence. On paper, it sounds insane. Heck, for everything we see in the universe, or heck, it kind of is insane. But we have several pieces of solid but non-irrefutable evidence to show that not only could it have happened this way, but it probably did. So this article right here is still leaning toward the idea that there's some kind of fluke in the data, I believe. But now that it's to the point now that we know that the data is correct. That decades after the background radiation was uncovered, NASA launched the WMAP to literally probe this. Okay, this is when they first launched up the first WMAP after they discovered that there was a thing called cosmic microwave background radiation. And this CMBR toll was going to tell them the age of the universe within 1% accuracy. Its composition, the universe is made up 72% dark energy, 23% dark matter. Normal matter only makes up about 4.6% of the overall mass of the universe. Think about that. 4.6% of what we consider as stuff. And everything else, they don't have a damn idea. They come up with this janky dark energy, dark matter, which I've never thought was right anyway. They don't even know what it is. The matter makeup was much different in the early universe. Dark matter dominated, but dark energy didn't exist in high quantities. It's highly probable that the universe is flat in geometry rather than curved like Earth. Okay, this is their idea right here. This is the idea that is no longer valid, that our universe is flat and not curved. Neutrinos, the crazy shape-shifting particles, are far more numerous than suspected. They also played a significant role in the early development of the universe. Those findings weren't all that unexpected, but WMAP and the newer Planck Observatory found various things that can't be explained using conventional models, several of which are, this is the cold spot. When looking at the data collected by WMAP scientists, noticed that in one distinct region of space toward the constellation of Eridanus, about 10 billion light years, the Earth CMBR showed evidence of a large hole in space. They aren't traditional holes, mind you, but spots where the temperature varies from the usual temperature 2.7 above absolute zero. One theory attributes this to the existence of a supervoid. This would be the largest one in existence, with it stretching about 1 billion light years in diameter. For the sake of comparison, the void found in the constellation of Bootes, sometimes called the Great Void, extends somewhere between 250 and 330 million light years in diameter, which makes it one of the largest voids we've found so far. Interestingly, not only is this region very cold, but it's also lacking in all types of matter, including normal matter, stars, planets, galaxies, and even the most basic material like gas and dust. Even dark matter itself is strangely absent. Some astronomers suggest that the Eridanus cold spot is merely an arbitrary data artifact that means nothing, but the Planck findings cast doubt on that notion. So if it does indeed exist, and it does, how did it form? Well, the most plausible solution posits that the hole was created as CMB microwaves made their way across the universe to Earth, encountering many regions that, like the hole itself, were lacking in stellar material. The intergalactic journey through these regions affected them in the opposite way that traveling through hot, dense galaxy clusters tends to inflict on said microwaves instead of accumulating energy through the pull of gravity. When they pass through a void, they do not gain additional gravity, thus, the temperature recorded in the CMB is noticeably cooler. Now, for some more fringe hypotheses, the physicists have suggested that the void is an imprint of a parallel universe. The view might, supported by the recent discovery of a corresponding void located on the opposite hemisphere of the CMB, at least according to Laura Houghton, a noted advocate of the landscape multiverse hypothesis. Another physicist purported that it could be universe in mass black hole, but the claim is dubious at best. Even if it would provide a source of all the missing matter in the universe, the void appears to have shed uncertainty over various standard cosmology models, which say such large-scale structures like the enormous void shouldn't exist in the universe, should be more or less the same everywhere we look. Either way, one thing is for sure. When we see such blatant, huge area that doesn't fit the bill, notions about the universe get shaken up quickly, and a lot of new questions demand answers. Answers that will be controversial, regardless of all else. Well, that's to say the least. Let's see here. Uh, where is the one that I was just looking at? What is this one? Let's see, I don't believe this is what I was looking for. No, there is a really good article that just lays all of this out very nicely, and I had bookmarked it, but apparently, let's see, hold on, let's look down here. No, 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 no. This is just tickling me to death. I can't believe how ignorant some of the smartest people in the world are. I mean, they would literally rather fight tooth and nail to explain something that is all of the data is pointing to being wrong. I mean, it, it, they're going to have to literally go back and redo the entire idea of the structure of our universe, because it's wrong. Um, Everything in the Bible is turning out thing by thing to be more correct than any standard uh, physicist view, and that's just great. I mean, I already knew it was that way, but I think that at this point in time, this is the perfect time for something like that to come to light, because we are so close. At the end here, everything is going to come out. We're gonna figure it all out. The truth is going to come out, and it's not going to be anything like what mainstream has told you. I feel sorry for all of the people that have put so much faith in science when they should have been looking at their Bible, um, because it's all right there. And and I knew about all of this from a long time ago. What's new about this right now is the new Planck satellite that's pretty much definitively proven that we are the center of the universe. The universe is not flat. It is curved. It's finite. Also, it messes with time travel, because another one of the anomalies was the about the nucleus of atoms. What it boiled down to and basically says is that time is definitely moving in a direction, and that direction is from past to present. It doesn't allow for backwards. Time is definitely moving forward. Um, Man, I've got to find that. Got to find that other article about that, because it's so good. Let's. I bookmarked it, but apparently my bookmark didn't want to hang on to it. Here, let's see what we got here. Maybe it's through this. Um, let's try this one. This could be it. No, that was the very good article that I just read you. Let's see what else we got here. Oh, and this name right here, Axis of Evil, is so funny, because I mean, it's just turned their whole idea upside down. And if you put religion and put the Bible aside, and just look at what the evidence has said, um, they're gonna have to literally come up with a whole new idea about what happened, like what the structure of our universe is, because it's wrong. They've got it wrong, and it's going to have to be this is going to be a very cool time for physicists and theoretical physicists, because they're going to have to come up with a new idea. um this is Hey, I tell you what, I will tell you what, we'll find it just like this. um Axis of Evil, no, we'll go right here to history, and I'll find it right through here. Cataclysmic variable. No, this is when I was looking up some stars that we just found. Um, Hemispheric. Here, this is it. Flat Earth, Flat Universe Society.com. I know this video is going to be long, but this is important. And okay, This site right here, everybody should go and take a look at. Flat Universe Society. This very well goes over the anomalies, accelerating expansion. It has it all laid out very precise for you. The anomaly 98 announced that astonishment of the cosmological community that based upon their detailed observation of the velocities of type 1a supernova, the rate of the universe's expansion was increasing, not decreasing as had been assumed. Their data, when plotted on the graph to the left, best fit the line shown in the yellow that corresponded to the universe whose expansion was accelerating with time. Up until this point, the model for the flat universe had assumed there was enough mass and energy in the universe such that the expansion would simply continue to slow down forever, never quite stopping. There did not appear to be a sufficient amount of matter to reverse its direction into a contraction mode. The current flat model of the universe, however, provides no explanation as to why the rate of expansion is speeding up. The argument. To address this apparent accelerating expansion of the universe, the current flat model requires that some force must be acting on matter at the largest scales of the universe, and that there must be some form of energy pervading all space because we're unable to detect it. Scientists have given it the name dark energy. It is assumed that at intergalactic distances greater than galactic superclusters, the force exerted by dark energy becomes stronger than gravity and is the underlying factor causing the universe's expansion to accelerate. Dark energy is assumed to make up 68.3% of the universe's mass and energy. This mysterious, fictional, theoretical dark energy makes up 68.3% of the universe's mass and energy. Wrap your mind around that. However, as it continues to elude detection, never found it, don't know what it is, never seen it, only exists in the chalkboard or whiteboard of a, university physicist. Dark energy remains a mystery. On the 4th of October 2011, the Nobel Prize was awarded to Reese Perlmutter and Schmidt for the discovery of the accelerating expansion. That is just hilarious. Many of those who followed this story since their 1998 discovery might condense the trio's find down to those two words, dark energy. However, following the wind, Reese stated, now that the accelerating expansion seems to be the smoking gun of dark energy, but we still don't understand what dark energy is, or even there's the outside possibility that we don't quite understand the laws of gravity and that there really isn't this dark energy. So the fact that we see the universe accelerating is really the tip off that something interesting is going on, either on the gravity side or the content side of the universe. Listen to what this man is saying that just they gave the award to. He is saying that they don't know what gravity is. They don't know what dark energy is. He don't have a fucking clue what's going on and why it's happening. But he's just made up an idea and it sounded good enough to work with the data they had on hand. So bam, he gets a grant and an award. And now we're seeing that all of it is wrong. I mean, this is so hilarious. This is the state of our idea of the universe. They would instead of having theology in the possible existence of intelligent design or a god, they would rather go with an idea that has no basis in reality, that it's nothing. I mean, it's like me saying French fries are holding up the earth, and the Hamburglar is slinging shit out, stars out from planet uh, Burger Lot over there, and that's what happened, and that's why we have, things the way they are in the universe. And they give me a Nobel Prize for it. I mean, that's basically what we got going on here. And it's just, I can't wait to see what comes up. They can't ignore this anymore. Um, there's so many anomalies now that the entire mainstream idea of the Big Bang, the structure of the universe, it's all going to have to be rethought and redone, and nobody's even talking about it. We have no. This is the biggest thing in science, in history, probably the biggest thing in this century, and nobody really has a damn clue about it. So, um, I'm going to do a couple more videos on this, a little bit more in depth, but the general idea is there. And please go check out the Flat Universe Society and share this information with your friends because it's about to get hilarious. Have a good day.